Right, so we're on to assignment 3, and this is a calculator assignment as well. Okay, so it says the line y equals 3x plus p and the circle x squared plus y squared equals 53 intersect at the points A and B. Show that this quadratic holds. Now what you need to do is you need to use substitution. So you need to replace y with 3x plus p in here. Okay, and I'm going to do that up above. So we're going to write x squared plus 3x plus p squared equals 53. So I've replaced y with 3x plus p. Now what I'm going to do then is square this out using a grid. So 3x plus p squared. So I'm going to do it over here. So you've got 3x plus p, 3x plus p. So you get 9x squared in that box, 3px, and p squared. So if I'm going to tidy all this up, it's x squared, that's that bit, plus, and then if I add these up, I get 9x squared plus 6px plus p squared equals 53. Now, if you add 9x squared and 1x squared, you get 10x squared plus 6px plus p squared minus 53 equals 0. Okay, now that is exactly what they write there. So that's what you had to show. You just had to show that using algebra. So the coordinates of A are 2, 7. That means that when x equals 2 is a solution and y equals 7 is a solution. So what we can do is see if using this coordinate, right, we know that those two numbers will work in this rule, y equals 3x plus p, so that allows us to work out p. So what I'm going to do is I'm going to replace x with 2 and y with 7 up in here. So I'll write the equation out. It's y equals 3x plus p, and if I replace those in, I get 7 equals 6 plus p, so p must be 1. So if I put that in there, I get 10x squared plus 6x, and that's 1 take away 53, okay, and that makes minus 52 equals 0. So I'm ending up with this quadratic here. Now what I can do is divide through by 2, and I get 5x squared plus 3x minus 26 equals 0. Okay, yeah. Now I can use the quadratic formula on this to try to solve it for the two answers, right? And what I'm going to say is minus b minus 3 plus or minus the square root of b squared, which is 9, minus 4 by 5 by minus 26, okay, all over 2a, which is 10. So let me type this in under the square root. I'm getting 9, 20 by 26 plus 20 by 26. I'm getting 529, that is, so it's minus 3 plus or minus the square root of 529 all divided by 10. So square root of 529 is 23. So it's minus 3 plus or minus the square root of, or sorry, not the square root, 23 divided by 10. So one of the answers is 2, as you'd expect, which is that coordinate there. And then you get minus 3 minus 23. The minus answer is minus 2.6. So those are your x answers, right? And so that's going to be the x coordinate for coordinate A. So I need to find the y coordinate for coordinate B, because coordinate B is going to have an x coordinate of minus 2.6. And to get the y coordinate, all you need to do is triple it and add 1. So minus 2.6 multiplied by 3 plus 1, and I get minus 6.8. So that is going to be the coordinate of B there. Okay, quite a tough question. To go back over it again, what you needed to do was substitute that in and multiply it all out, and you got this equation. It told you the 2, 7. Okay, the coordinates of A. Remember, it says that this and this intersect at A, so A must satisfy this equation here. When x is 2, y is 7. So if you put 2, 7 in there, that'll allow you to get p, which was 1. And if you put p as 1 in here, you get a quadratic that you can solve to get the rest of the answers. So, second problem is the diagram shows the side view of a step ladder with horizontal strut 48. The strut is 1/3 of the way up the ladder. So see this here, 1/3 of the way up. If you divide 141 by 3, so this is 47 here. See that distance there? And if you take 141 minus 47, that's 94. That's 94 there, okay? And the symmetrical cross-section of the ladder shows two similar triangles. So what I'm going to do is I'm going to draw those triangles out side by side, okay? The big one and the small one. So the big triangle, what do we know? We know the small one, sorry, we know that this is 94. Okay, that's the small one there. And we know that the base of it is 48. The big one we know is 141. And that's all we know. But if we compare 141 and 94 by dividing them, you end up with 1.5. Okay, so the scale factor is 1.5. So if you multiply 48 by 1.5, right? I'm going to do that now. You end up with 72. So this is going to be 72 here. Now, what you're asked to work out is you're asked to work out the it says it's a symmetrical cross section. So if you look at it, this is what we've got. If I was to cut this in half, there's the height, perpendicular height of the ladder. Because this is 72 all the way along the bottom, if you half that, you get 36, and this is 141. So we can use Pythagoras' theorem, where I can say that 141 squared equals h squared plus 36 squared. So I'll type that in. 141 squared minus 36 squared is that, and you square root that answer, I'm getting 136.3 is the height. Okay, and that looks about right on the diagram. That's how you do that. Okay, this is a wee regions question. It says, Joe draws the graph of the following regions. Now he has that line in. Okay, he has 3 minus x, which is that line in. And he has x less than 3, which is that line. Make two criticisms. Well, the first thing is you need to be careful with these symbols. Where the symbol has an equals to in it, which is this one, it should be a solid line on the graph. Okay? And where it has a greater than or less than, it should be a dotted line in the region. They should be dotted. Now, if you look at his diagram, he only has one dotted line. So you see this here, the first criticism is this line should be a dotted line or a dashed line. Or a dashed line. So that's the first mistake he's made. He's drawn a solid line in there. Well, it should be a dashed line. The region he's marked R in the wrong position. He's marked it out here. Remember, the three lines are like fences, and you need to think about what field or a pen that the fences have made. There's one there, there's one there, and there's one there. So this is the actual region he's looking. See this one I'm colouring in, this triangle? Because that's the region bounded by the three lines. So he has it out here, which is out in the wrong. So the R should be in the middle, in the region, mark in the region. So that's the second criticism. That's why it's wrong. So two things he's got wrong. He's marked R in the wrong position, and this line should be a dotted line. Okay. Bottom question is about the cosine rule. So let's call this x. So x squared equals 6 squared plus 9 squared minus 2 by 6 by 9 by the cos of 120. So let me type all that in. 6 squared plus 9 squared minus 2 by 6 by 9 by cos 120, and you end up with x squared is 171. So x is going to be the square root of that, which is going to work out as 13.07. Okay, that's that sheet done.